Hi, this video will be a little bit about the history, about connecting embedded devices to the Ethernet or to the Internet at all. Yesterday I was playing with my really old Ethernet modules, and I needed to make some firmware change, and then I was thinking that it would be good to share this process with you. And after a few moments I've decided that I can compare the options to connect your embedded device to the internet now and 10 years ago, and how this all Wi-Fi modules enabled us to create really cheap and wireless devices connected to the clouds. Alright, so you probably know all these modules. This is the ESP8266 modules, these, and this. Then Realtek came with its own Cortex M3 Wi-Fi, which I haven't time to play with. That's shame. And this is the ESP32, which everybody's talking about. I bought this almost a year ago, and I haven't used this even once, so it's lying in my box. Right, and this is what I will talk today about. This is quite old Ethernet module, which I have designed. This is 2011, but I'm sure, yeah, this one is older. It's 2009, so it's almost 10 years old. It looks ugly. It was created by the PCB was created by a toner transfer method with a laser printer, with quite good outcome. And later I have added DC-DC switching power supply. There was a linear in the first revision, and this is a DC-DC. And later I have made professional PCBs. It was not so professional because the DC-DC step-down converter layout is really crap, and I would do that completely differently. And the other thing is it's only one layer board, and I don't know why I was afraid of two-layer boards. It was a stupid step to do only one single layer board. Maybe I was trying to make it as cheap as possible, but yeah, the DC to DC converter is working, but I don't know how good, because the ground is going there. There are circles like this big, and oh, the memories. And here's the first prototype. What do you think? Why is this the first prototype? Yes, typical. You create your footprint, and you don't compare the footprint to the part you have physically in your hand, right? So there was a smaller footprint on the PCB, and I had to somehow put this together. And also you can see there is much more air wires. Is there a date somewhere? Not yet. So this one would be the oldest, but I think it's the same date, the same year, 2009. And these modules I was using a few years ago. They were logging temperatures with simple Dallas one-wire sensor temperature. So I developed a firmware for these modules which scan the one-wire bus and displays the values on the web page. And you can also download a XML file from this and keep the values up to date, the measured values. Maybe it's a good idea to switch to the original code original project which I've started this from. And if you go all the way down to the 2006, then here's the original project I was which my design is based on. And yeah, maybe I can say that it's using AVR ATmega8 and AVR 168. It differs on boards. And this project is using the cheapest option that time, which was how to connect your device to the internet, which was ESP ENC28J60. And so yeah, this is the chip. And you just connected this chip to any microcontroller which has SPI, which was very important because that days you can connect Ethernet over RMII, reduced media independent interface, which was running on 25 megahertz, and you also needed some hardware peripheral on your chip, which wasn't cheap. So the SPI bus, which is here, was really good that time. This chip is able to run only to 10 megabits, not full 100 megabit Ethernet, but it doesn't matter because it's always compatible, and you don't stream a lot of data from the ATmega. And you also you needed just the Ethernet magnetics with the connector. So this project is dated 2006, which is also funny. It's more than 10 years ago, and it came with basic examples in C, which I have edited and added like HTTP or a REST API to control inputs and outputs, which were added on this connector. This board also has passive power over Ethernet, which means that two pins from the Ethernet jack are connected to the power supply, and you could enable and disable that by this jumper. So it's not the real power over Ethernet, which has some negotiation between the router or switch and the device. Unfortunately, a year ago there was a storm in my area, and some power surge killed almost all of these modules, and I don't have time to bother what was wrong with them. The LED Ethernet LED is blinking. The ATmega is possible to program, but and it seems it's communicating, but really it's not working, and I don't have time to debug this. And really, the ATmega, there's really not a good solution to debug this chip, so it will be lot of wasting of time. Then I will go back to this module because there's one thing. I have found two of these modules are working, but they are configured to different network. I have source code from this module, but I don't like to compile this because there's a lot of options. Like you can add infrared LED, you can add some RF transmitter, which was because I was doing this project, and I had my speaker controlled over infrared, which is here, and also when the speaker was turned off, then I sent a radio message to this power plug, and it completely shut off the main transformer, which was humming all the nights, and this was getting me crazy. So this is the site when you can see some info about this module. I don't have a dedicated website to these modules, but a lot of things changed since 2009, And for example, if you would like to create your device with Ethernet connection, forget about Wi-Fi, because Wi-Fi was not a cheap option at that time. So you could use the better processor. This one is Cortex M3. It's STM32F2. And between the processor and the Ethernet jack, you have to have the PHY chip, which is the chip that converts analog data from Ethernet with all the timing constraints to the digital stream with ones and zero just for your digital processor. And this chip is here, and this is the way you could create your Ethernet device, but there's 25 or 50 megahertz clock speed between the processor and this PHY, so it was not possible to take AVR or Arduino, if it was a thing at that time, and just have the internet working. So this still needed some better processor, and I started with ARM microcontrollers with this kit, and this kit has this PHY chip inside the main processor, which was excellent. You've probably, of course, you lost a few pins from the package, but it was really simple, and all the examples were working. So this kit was example start. It was ideal start to the Ethernet world. This chip was created by Luminary Micro, which was later bought by Texas Instruments with a Stellaris processor line. It's here. And later they have renamed this chip, this line to Tiva microcontrollers. This is even a web server on the wheels. Oh, that was awesome to play with this. I bought this kit with a discount because Hackaday showed some promo discount code, and yeah, it was not for the public. It was for some event. This promo code, but everyone was using this, and I'm sure they have to do like thousands of these kits instead of few hundreds. So, and then later the Wi-Fi really started to be easier and cheaper for makers. So you can use the ESP module and the kits. Of course, the Wi-Fi is not a solution every time. So when, for example, when I have a power supply somewhere to power these Wi-Fi modules, I can easily have also Ethernet here, so I don't use these boards or ESP modules too much. Maybe in a garage I have one ESP, but it's not working right now. I have to also repair that. Alright, so I would like to make a live few of these, or one of these. I take a look at the oldest one, which will be interesting, and let's try to power this on and see if it's communicating. I have the only one which survived that power surge voltage, and this module is working right now. Sorry. And you can see it's making quite nice HTML site without the new lines and no spaces. So I can save as much flash memory as I can. So this is the free temperature sensors connected, and you can see also uptime. I've turned that on yesterday. And if you write /info, you can see an XML file with all the sensors and values. So you can save these temperatures to the database. All right. So let's try to power on this module and see if it's running somehow. I have also this crappy cam to my power supply. So it should, yeah, it's showing 140 milliamps over here. And when I connect the Ethernet, yeah, the LED is on. This LED is also turned on and blinking. And I don't think I can see this device on my network because my network has different addressing. So I open the source code, which is here. And yeah, you can see text graphics. This is what I've used. And what do I need to do? Okay, here's the settings and prototype define, which decides what IP address and what MAC address the device has. So this settings. All right. So my latest network was the 100 network, and my actual network is using, sorry, is 0.1. So I have to change this. I have a utility which does that, but it's not working in latest Windows. It's written in .NET, which should also work in Ubuntu, but it's not. It's looking like this, and this should send a UDP broadcast packet and receive UDP packets and show the found devices here, but it's not working. So I could rewrite or reverse engineer this simple protocol, or there's another option to download actual firmware from the device, edit the IP address in a hex editor and save it back. And this is what I will do right now because the chip is not locked. Yeah. And also this first prototype has ATmega8, which has because the actual code is for the ATmega8 and there's a lot of if-def, and I'm not sure if I compile that it will work. So, and I need to set up the compilation. No, I'm really lazy. I just do it the old way. Change the hex file, change the memory. So close it. So now I need to. Yes, I will try to connect it to it with the actual IP address, but I would need to add. Add another Ethernet because all right, I have one Ethernet working on this address, and I need to add a second one. So I have searched how to add where it was secondary address to the Linux. So I need to use this command. Oh, I have so many windows opened. Oh my God, let's close a few of them. All right, this one will do. So this needs to be called with sudo ifconfig now enp 6S0. Now the IP address, the 100 network, and let's say 5. Net mask, typical, and up. Alright, I have another interface working. So let's try to nmap SN. I need another hint, which was, yes, /24. And it has found one device, which is awesome. Is it our module? It is. And as you can see, this web page is completely different from the web page which was for ATmega8 because of the memory, the flash, and the RAM. And also the info stays the same, which is good. I can actually try to add a temperature sensor. Alright, then restart the board. Okay, it has found the temperature sensor. I have cold hands, so this could go lower. Now it's going up. Not so cool. Okay, so the hardware is working. I need to change the IP address. So I need to program this device. I hope there's a programming header. It is. And I need a programmer, which is here. This is a tic-tac sized ATmega programmer, which I did years ago. Is there a year of manufacture? No, it's not. But there's a full size PDIP chip, PDIP28, and then the big USB connector, and some jumper and wire. And it's working, and it doesn't make a short circuit when you put this on the metal surface. And this thing, this is the 5 volt to 3.3 volt voltage divider. It's made of simple resistors and 3 volt stabilizer. And this was actually a funny project because I was using Eagle and I was trying to make nicely curved tracks. All right. So let's connect this to the computer and see if this will be detected. It is USB ASP. This is actually another AVR 168, I think, which has software USB support, thanks to this guy, and he made programmer for this. And then I will use the AVR Dude, which I hope I have. Yes, I have installed it. So now the connecting. If I connect this wrong, then I can stop the stream. Pin number 1. Let's try this. Alright, how do you use AVR Dude? Because I was a Windows person 1 year ago, so I'm still translating to Unix, to Ubuntu. AVR Dude. What? So I need some help. I need P. I will probably Google that up. look, I was there a while ago. C, yeah, this one. And the chip, which is ATmega8, I think. It is. So M8 with parameter P. Target doesn't answer. Oh no. Do I need to use the slow speed? Okay, it's working. Why was that? Oh, it's working, just something was wrong with the wires. All right, so I can communicate with the AVR. And what I would like to do is read the flash memory. So another help, which is here. No. Oh, here it is. So I would like to read, not low fuse, but memory, but I think we can use this. So what's the command? U flash read flash.bin, and then I need the format for the file, which will be R for raw. So read. I hope I don't overwrite this. Okay, there's some different signature. Okay, it's working now. The second try. It's weird. And I have flash.bin. All right, let's take a look at this file with the hex editor. So this file is 7 kilobytes. Yeah, it's ATmega8, so it's a really small chip. And what I need to find is this, or I can find the MAC address, which always starts with these 3 bytes, no matter what the prototype is. So 5455, I will try to take a look to find. No. So where the MAC address? 190. All right. So let's try find the IP address, which is 192.c0 168, which is A8. All right. So C088 A8, also none. So where this address is saved? It's MAC. Oh, it's saved in EEPROM memory, which is fun because I'll do a lot of work on Cortex-M processors which do not have EEPROM. I faked it with flash memory, so I'm not really used to remember that, hey, AVR has the flash. So let's do it once. Let's instead of flash EEPROM. Will it work? EEPROM. Seems like we have EEPROM. How big is it? So it did not save the file before, so yeah, 512 bytes. And oh, we have IP address and we have MAC address. And now I remember, because this yeah, the original creator of this firmware choose the MAC address that will be possible to read in ASCII, which is fine. Okay, so MAC address will be the same. I just changed the IP. So I keep the F1, which is something before 250. 241, right? I write this down. And I change the network from 64 to 1. 0, 1. And that should be it. Save file, alright. Now let's try to write it back. So instead of read, I add write, and this will be unnecessary, I think. Writing takes a lot more time than reading, and it seems it's okay. Now the moment of truth. So this is not true anymore. It's working. No. All right. Yeah, I have the 0.1 address. So the module is working, and also the temperature is changing, which is fine. Okay, so I think this is all for this stream. It's not a stream, it's a video, yeah. So I can put this module somewhere to measure the temperature, probably somewhere outside. Alright, that's all. So thank you for watching. If you like this kind of video, you can support this video with thumbs up, and subscribers are always welcome. And yeah, you can write your own stories of Ethernet if you have some experience 10 years ago, like me. how were your beginnings? And okay, so thank you, and see you sometime next time. Bye.